Okay, today's lesson will be on section 7.4, double and half angle identities. Today's lesson will focus on the double angle identities. Let's say, for example, you're using the sine addition formula. However, you're adding the same angle. So we can use the same argument, theta plus theta. And if we expand using the sine addition formula, we get sine theta cosine theta plus cosine theta sine theta. And because of the commutative property, we can switch the second set to become sine theta times cosine theta, plus the first set, which is sine theta plus cosine theta. Combined like terms, we have sine of 2 theta is equal to 2 sine theta cosine theta. So we can end up making a whole set of new angle identities from what we learned with our addition formulas. And there is only one for sine of the double angle, which is 2 sine theta cosine theta. Similar methods could be used to show cosine of the double angle. However, cosine of the double angle has 3 different formulas, all work. You don't have to do all 3, so you do the one that's easiest with the information that is given. So the first cosine double angle is cosine squared theta minus sine squared theta. Cosine 2 theta is equal to 2 cosine squared theta minus 1. And cosine of 2 theta is equal to 1 minus 2 sine squared theta. And then tan of the double angle only has one formula, and it's 2 tan theta over 1 minus tan squared theta. So depending on what the question's asking, if they want to know the sine, cosine, or tangent of the double angle, these are the sets of formulas that you use. And if you still have that formula sheet that I gave you, you can use it as well. So we will start with finding the sine of a double angle given some information. If sine theta is equal to 2/3 and theta is in quadrant 1, find each of the next values. Okay, so we're going to find sine of the double angle. And since we want to know sine of the double angle, we're going to use its formula's identity of 2 sine theta cosine theta. We're going to draw our triangles like we did before. Remember the bow tie, so we're in the first quadrant, so we're drawing this part of the bow tie. We know sine is opposite is 2. We know sine's hypotenuse is 3. So we can use that with the Pythagorean theorem and figure that 3 squared is equal to 2 squared plus x squared and solve for x. So 9 minus 4 is going to give us 5, and then we square root that, we get plus or minus root 5. But since we're in the first quadrant, the root is positive. So sine theta of this triangle was given, so that was simply 2/3. So we can simply put that in 2/3. And then cosine theta is adjacent over hypotenuse, so that's going to be root 5/3. And we can put this first 2/1. And we can multiply that all together. So 2/1 times 2/3 times root 5/3 is going to give us 4 root 5/9. And that is our answer. Now I just stopped my recording and restarted it, so just like if I'm going too fast, you can always just pause it and go make sure you're getting the information and then move ahead, or rewind it however you do. My next example was going to use the same information. However, we're going to find cosine of the double angle. So again, sine theta is equal to 2/3, and theta is in quadrant 1. We're going to find cosine of the double angle. Now here you have 3 choices. So always choose a formula that involves only the given information if possible. Now I'm going to do the formula 3 different ways so you can see that you're going to get the same answer regardless. But remember, when you do it, you only have to do it one time. So they gave me information of sine theta was equal to 2/3. So one of the cosine double angle formulas only uses sine. So cosine of the double angle is equal to 1 minus 2 sine squared theta. So then I can fill that out. So 1 minus 2 times 2/3 squared. So I need to square 2/3, multiply it by 2, and then subtract it from 1. And when you do that math, you end up getting 1/9. Now, Since I had the information from the last problem of the value of cosine was root 5 over 3, I could also do the cosine squared theta minus sine squared theta version. Okay, so it's going to be root 5 over 3 squared minus 2/3 squared. So root 5 over 3 squared is 5 over 9 minus 2/3 squared, which is 4 over 9, which is equal to 1/9. Same answer. I could also have done the 2 cosine squared theta minus 1 version of cosine's double angle formula. So I could square root 5 over 3, and I could multiply it by 2, and then I could subtract 1. So 2 over 1 times 5 over 9 minus 1 gives me 10 over 9 minus 9 over 9, which is equal to 1/9. So you can see in all three situations, I end up with an answer of 1/9. So it doesn't matter which of the three forms you use, you will arrive to the same solution. So again, using the same information, if sine theta is equal to 2/3 and theta is in quadrant 1, we're going to find tan of the double angle. Now tan of the double angle is equal to 2 tan theta over 1 minus tan squared theta. So I haven't found tangent yet of the given triangle from the very first example, but we can go ahead and find it. So tan theta is going to be opposite over adjacent, so that's going to be 2 over root 5. So basically, we know the value of tangent. We can plug it into the formula. So tan of 2 theta is equal to 2 tan theta over 1 minus tan squared theta. Well, I put the 2 over 1 and then 2 over root 5 in the numerator. Then in the denominator, I have 1 minus, and I'm going to square 2 over root 5. Notice I didn't rationalize it in the beginning. I'll always wait till the end to rationalize. Otherwise, you'll be rationalizing quite a bit. So I multiply the 2 in the numerator, and I end up with 4 over root 5. And the denominator consolidates to be 1 minus 4/5. So that's going to be 1/5. So basically, we're going to do same change flip on this fraction. So 4 over root 5 times 5 over 1. And at this point, I'm going to simply simplify the fraction. Now is your time to rationalize. So 4 times 5 is 20, and then root 5 times 1 is root 5. So 20 over root 5 will then get rationalized by using root 5 over 5. And that's going to be equal to 20 root 5 over 5, and the 20 over the 5 cancel into be 4. And so that's equal to 4 times root 5. That's your final answer. So for this last example of the double angle formulas, I'm going to give you a scenario, and you go ahead and pause it, and you try to work it out. And once you're done working it out, unpause it and go through the rest of this end solution. Okay. If cosine theta is equal to 3/4 and theta is in quadrant 4, find each value. Find sine of the double angle and find cosine of the double angle. Okay, go ahead and pause it and you work them out, and then turn it back on and see if you were right. The first thing I'm going to do is create a triangle. So I'm going to create the bow tie in the 4th quadrant and use my given information of the adjacent side being 3 and the hypotenuse being 4, and finding my opposite side being a negative root 7. 16 minus 9 is 7. Square rooted is root 7. And since it's in the 4th quadrant, the y value is negative. So we can write that up here, 16 minus 9 equals 7. And then we need to square root 7. So sine of the double angle is going to be 2 sine theta cosine theta, so 2 over 1. And then I got to find the sine of theta, which is going to be opposite over hypotenuse, so negative root 7 over 4. And then cosine theta was given, which was 3/4. I multiply that all together. My product is my answer. So a negative should be my sine. And 2 times 3 is 6 root 7. And then 1 times 4 is 16. Now 6 over 16 will simplify, but my solution will be negative. So my answer should be a negative 3 root 7 over 8. Now, I normally always make a grocery list before I start of things I need, and cosine theta was given and sine theta was found. So it's always a good idea to make a little grocery list before you start, then it's easier to fill out your formulas. The rest is just calculation. Now, for cosine of the double angle, I will have it worked a couple different ways, just so you can see that they still arrive at the same solution, but you only have to work one. So cosine of the double angle is equal to 2 cosine squared theta minus 1. And that's equal to 2 over 1 times 3/4 to the quantity squared minus 1. And that calculates down to be 1/8. I could have also done 1 minus 2 sine squared theta, which is equal to 1 minus 2, and then the negative root 7 over 4 squared. So then this will be 1 minus 2 times 1 multiplied by 7 over 16. So basically that becomes 2 over 16, which is 1 over 8. Now the third method would be to say cosine squared theta minus sine squared theta. So I could have said 3/4 squared minus a negative 4 to the quantity squared. And that would have still given me the same solution of 1/8 once you multiplied the fractions, or squared the fractions and then subtracted them. So either way, you would have gotten the same answer. Okay, so I'm going to give you some problems from section 7.4 and probably about 5 or 6 and let you try this. And I will post it on Google Classroom what your assignment is. Tomorrow I will give you a lesson for half angle. Thank you.